Yeah, sometimes if I miss to record, at least if someone can see and let me know so that we don't miss the recording. Okay, so now one of the scenario that we saw in the last session is when you have a branch and that branch is being created only for you and no one else wants to have a workspace in which they will have a branch similar to what you have. So in that case, now in order to share the changes from your workspace in the particular branch that you have created, first we will try to merge it to the master branch, and from the master branch we will try to push it to the central repository. So that is the first scenario that we saw. Now suppose on the other scenario where the branch on which you have created, that is the parallel release branch, everyone is working on it, or there are a couple of others who are also interested to work on the same branch. So then what is that we have to do is, now first we have to make sure that this particular branch is being available in the central repository. So that is how, if we want, I can directly choose to push from the particular branch to the central repository. And if someone is trying to create a workspace, a clone, then he will also be getting all these branches into their workspace. So how is that you're going to share your particular branch that you had in your workspace? Now to do that, all you have to do is now simply just say git push -u -all. So until now, what is that we were doing? A push means from your workspace on the default master branch, whatever that you had, you were pushing it to the default master branch on the central workspace. So that is what exactly push was happening. So now if you say push -u -all, -u means consider everything in your repository. So along with this master branch, it is also going to consider one more branch that you have. And in that branch also, whatever you have, everything together from the repository of your workspace, it will be pushing it to the central repository. Okay, so to do that, first let's cross check. I'll go to the central repository. And here, if I do a git branch, I'll not be having it. So now if you simply do a git push -u -all, then along with the master branch, whatever other branches that you have, that means the entire repository content, you're trying to store it to the central repository. So that's how now whatever the Windows release branch that we have created, now it will be available in the central repository, and anyone else who wants to work on that, they can go ahead and work on it. Okay, so here if you look, you can see that that branch is also available. Now when I say the branch is available, obviously it is not just the branch, but inside the branch whatever you have, the contents, that is the commit ID, will also be coming into the central repository. So that's where the second scenario on which everyone wants to work on the same branch. So going forward, if anyone now is trying to create a workspace that is a clone of the central repository, at that point of time, whatever he has, he will be getting. So that way, the new workspace, the user will also be getting the Windows branch in addition with the master branch. Let me open up one more command prompt and we'll see in it. Anyway, I think it's okay. Okay, so here now to cross check on the here, if you see on the other workspaces you do not have. So now let's create a new clone. So I'll say git clone central and new workspace 04. Okay, and in this, if you go now, okay, and if you do a git branch, whatever the contents I had in the central repository should be available here, right? So if I do a git branch, how many branches that I will be seeing here? 2, right? But it will not be showing. Now, what is exactly happening? Now, if you do a clone, whatever is available in the central repository should come to your local workspace or the repository. But why is it not showing the other branch? Now, to understand it, the concept that you have to understand is, now from your workspace, that is the clone of the central workspace, Git has actually created. And now the repository on which you are working, you are currently pointing to the master branch as default. That is why it is showing only that. Whereas the other branches that whatever you have is also available in your repository. But unless and until you switch to that particular branch for the first time, it will not be appearing. Okay, so to understand it, instead of just saying git branch, if you just say -a, it clearly says that as of now, how is that I am pointing to master branch? That is because by default, this is the branch in which the contents will be viewed. And that is why whatever the contents you have in the master, you are seeing it in the working directory. But the other branch that we have is available, but unless and until you don't switch to it, it will not be physically appearing it on your repository. So that is why it is saying that the other branch that we have is still pointing as a reference to the original, that is the central repository. So from this, it has created a reference and it has put it inside your workspace. So as of now, for the Windows branch, the reference is still available. But as soon as you do a checkout to that, then the complete copy of the Windows branch or this particular branch from the central repository, it will try to put it inside your workspace. So if you simply say git checkout and the other branch, so now physically what it is doing is it has removing the reference and it is creating a new branch under your workspace. So now if you do a git branch, you can see both of them are available. So it is only for the first time. What exactly Git does is it will be creating a clone. Clone means it is an exact replica of this. So unless and until you go inside it, it will be still pointing as a reference. But as soon as you go inside it and start using, then in order to view it, you have to have a copy of that completely inside the workspace. So that is how it will create a complete copy only if you switch to it. So make sure that as soon as you go inside the particular workspace, just try to do a checkout of that, then everything will be available. But until then, it will be just pointing as a reference from your central repository. Okay, so this is the second scenario where you will be interested to create the same branch across different workspaces. So now all the users, if needed, they can work on the master branch, or if they are interested, they can work on the Windows branch. So they can switch and they can do the changes and they can do the push from here specifically. So the workflow is going to be the same thing. Okay, so that is the other scenario when you want all the users to have the same branch and they should also be working on the same release branch for parallel development. Okay. Now, in this, there is one more concept that we need to know is, let's go back to the merge. Now, if you see what exactly is merge, let's try to recall. So merge means whatever I had in the source branch and that which I don't have in the other destination branch, it will try to take from here and it will put inside this. Correct? That way, when you are trying to merge from one branch to other branch, by default, it will take all the commit IDs, whatever is available in the source and whatever is not available in the destination, it will put everything. Now, let's say you created some 3 files in it, and for that 3 files, you created 3 commit IDs. So when you do a merge, what will happen is all those 3 commit IDs will be taken at one shot for the merge and it will be put inside the destination branch. So be clear in this. When you say merge, whatever commit IDs that is not available on your destination, that is available on your source, everything will be taken, and at one shot, all of them will be stored inside this. So that is how, when you have more than one commit IDs, when you do a merge, everything will be merged to the destination. So in our example, when we did the merge, if the Windows branch had more than one commit ID, everything will be taken and it will be trying to put it into the master at one shot. So that is the normal behavior of the merge. But if you look, the purpose of doing a commit ID first in your repository and then doing a push to the central repository is you should have the freedom. But now, let's say a developer first did a commit and he did it by mistake. And on top of that, he fixes and he gives one more new commit ID. Okay, so that the latest commit ID has all the fix. Now, by mistake, if you do a push, what will happen? It will take every commit ID, all the commit IDs. Same way, if he tries to merge from here, both the commit ID that he first created, which is going to have the problem, and the latest commit ID, both are going to be merged into the destination, right? So in this scenario, now at any point of time, if we have to merge only one commit ID, like you are choosing which commit ID that you want to merge, then you will not be using the merge command. So instead of the merge, we will be using a command called cherry pick. Okay. So the difference between merge and cherry pick is, for the git merge, if you give a source branch and the destination branch, then whatever commit IDs that you have in the source branch that is not available in the destination branch, it will take everything in one shot. It will try to put it. Okay. Now, instead of the regular merge, if you go with cherry pick, then in the cherry pick, you will have to specify what is the particular commit ID that you are interested to merge. So that way, instead of taking all the commit IDs which is not available in the destination branch, you will specify only those commit ID which is of your interest. Okay. So now here, this is the source that you are telling to take from a particular branch, but what is the destination? So if you do not give a destination, then by default, it will be taking as the current branch on which you are running. Okay, so that is how the merge or the cherry pick takes the destination as the current branch on which you are working. So like that, now if needed, you can do a merge completely, or you can specify only a particular commit ID and do the merge. Okay. Now let's try doing it. So let's say I'll first go to the Windows branch, and in this, let's quickly create a file called 6.java. Okay, and we'll add it and commit. And corresponding to this, you would have got a new commit ID. Okay, now we have one commit ID. Now let me create another file. I'll create another file, and in this, what I'll do is, let me try to put some content. For example, line 1, and I'll say Windows branch. So what I'm doing is I'm just creating a file called 7.java and I'm trying to put a line into it. Now let's add this again. Commit it. And corresponding to this, you would now have got one more commit ID. Okay, so now we can see these two commit IDs are newly created. Now let's go to the master branch. Okay, now in the master branch, you will not be having these two. So let's see that. So I don't have these commit IDs. Now from this, I'll try to do git cherry pick. Okay, and then I will give a commit ID. Now let's say I want only this. Okay, now before that, you can see, okay, master also has a 6.java. Fine, then let me try to do a commit of only this. So I'll say git cherry pick, and I will try to give the commit ID, where this commit ID corresponds to what? Only this file called 7.java. Okay, I'm not interested to take this 6cdde. Okay, and now for this, I'm not giving a destination branch. So by default, the current branch on which we are working will be taken as the destination. So this commit ID from the particular branch in which it is created, that is on the Windows branch, it will be trying to merge to the current branch, that is the master, as the destination. Okay, so you can see we got the file, and let's try to do the git log. Okay, now can you look here? I'm just comparing these two. So earlier, this was the commit
Hello.
ID that we had.
Hello, Adam. To interrupt you, could you please tell me that why we use the cherry pick option?
That is what I'm trying to show. So now, when we did the cherry pick, it is actually a merge, but we are not merging everything from the source, but instead we are merging only a particular commit ID. So that is how, if you see now, after this, we have merged only one commit ID, and we have not merged everything from the source branch to the destination branch. Because if I did a merge, what will happen? By default, it will take both this commit IDs from the source branch, that is Windows branch, to the destination. That's what we did last session. That is, when you do a merge from one branch to other branch, whatever the commit ID that is not available here, everything will be taken at one shot. But instead of taking it, if you want only a particular commit to be merged, then you will use a cherry pick. Cherry pick means don't merge everything, pick only a commit ID of your interest. So that is how now we did the cherry pick of only this. That is why after this commit ID, it has merged only this commit ID. It has not considered this. Whereas instead of the cherry pick, if I had told a git merge, then it would have taken both. That is the difference between git merge and cherry pick. Cherry pick means pick only a particular commit and merge. And the regular merge is by default, it will take all the commit IDs which is not there and it will merge.
Okay. Okay. And one more thing. And if whenever we are merging entire thing from one branch to another branch, if the both branches are having the same files, then what would you do?
I'll come to
Like,
that.
will it? Okay. Okay. That would be fine. Thank you.
So is it clear on what is a regular merge and what is a cherry pick? So now the developers have the flexibility where they can store as many commits they want in their workspace or in their branch, and they can choose which one particularly you want to merge, and then they can try to push only that. So that's the advantage, where now they can choose whether everything to merge or only a particular commit ID to be merged. Okay, getting it? All right. So now we saw that depending on the need for a user, he will be trying to work on a parallel branch which could be used for a release, or he can create his own branch. Now let's say I want to do some testing, then I can create another branch. Rather than storing everything on the master, I can create one more branch, do the changes in it, and then use cherry pick or merge to exactly merge those changes or all the changes from the test branch to the master, so that we can push either from our release branch, that is the parallel release, or directly on our master branch. So as the question came up, now many times when you say the parallel release, the contents and the files will be almost same, other than certain features are going to be changing. So that is when there will be a set of files which will be common for both the branches. So what will happen if the same file has modifications? Now in case if you don't have a file in one branch and you're trying to merge, then it is clear that you don't have, so let me merge. But if we have a problem where the same file had to be modified for both the branches, so let's say for both the release you had to modify a same set of files, then the content in one of the file will be different and the content from the other file will be different. So that is when you will be getting a merge conflict. Okay, so conflict is nothing but Git doesn't know how to resolve, because there will be a file on both the branch and both the branch has its own content, and when you say to merge, whether you should be taking the content of this branch or the other branch, the Git will not be knowing. So that is when we have to resolve the merge conflicts manually. Okay, so to do it, let's try to first create a scenario for the conflict. So now we have this file, right? Now quickly, if you look at this 7.java, you have this line called what? Line 1 Windows branch. I'll try to change this, and I'll try to change from the Windows to master. Okay, so now the 7.java which I have in the master branch has a content called line 1 master. Okay, this is what we have. And if I want, I'll add one more line to it. Okay, now I'll say second line is line 2. So this is what the content I have. So 2 lines in which first line says master branch and second line is just empty. Now let's do a git add. Okay, so we have committed, and corresponding to it, we would have got a commit ID. Now let's go to the other branch and let's open this file. Now in this, if you see, the content is Windows branch. Okay, whereas in the previous one, it was master branch. In this, let me add another line called line 2 in this. Okay. So this is the content what I have. Okay. Now here, let me add it. Okay. So now if you look, we have a content from the Windows branch on the file called 7.java is this. The same thing if you go to the master and if you see the content, it is little different, where the first line is different here, the first line is different, and in fact the second line also is different because I have put I in small here, but I have put I in caps, and the second thing, there is a colon here, there is not a colon here. So pretty much now the file is same, but the contents is different in lines. So now any point of time, if you're trying to do a merge from your source branch or the destination branch or a cherry pick, pretty much now it will be a conflict that it will be showing. So let's try to do a merge. So I'll say git merge the source branch and the destination. Suppose if I don't give the destination, then your current branch on which you are working will be the destination. So it clearly says that now there is a conflict on this particular file. Okay, so how is that it is going to show the conflict? If you open the file, it will clearly show now on each line, or wherever the conflict is happening on each of the line, it will be trying to show that what is the conflict that is happening, and in that it is going to clearly show what is the content you are getting from the source branch and what is the content you are having in the destination branch. So how is it going to differ? So the first thing now you can see, wherever the line you have which is having the conflict, it will be showing it in this way, separated by this line, where the one that you have on top of that is your destination branch. Okay, and the one that you have below it is the source branch. So the left arrow indicates that this is the current branch on which you are trying to merge, and the greater than represents the source branch from which you are getting it. So now it is, Git doesn't know now what to do. So that is why it is trying to show it clearly like this, where we have to now choose what is the content that I want to do. Suppose if I want to replace this and keep this, or if I have to mix both of them, it is up to us to choose and then proceed. So first, to resolve, you open the file and modify the content, in which make sure first you delete all these supporting data that is giving. So these lines. Okay, now out of this, which is the one that you want to keep? Now let's say, since this is a master branch, I don't want this particular data, but I want to keep the other two lines. So I choose whatever that I want, and then I save the file. Okay, so now you can see that the content is exactly as what you want, but it has not yet committed. It has done a modification. So because of this, if you do a git status, you can see that it is saying it is a file which has not yet been added to the staging area, because we have just modified the file. So just like how you will do a normal commit, you go ahead and add it to the staging area, and then you do a commit. Okay, so like this, what Git is going to do is, on each of the file where it is having a conflict, and in each file, whatever lines that it is trying to have a conflict between the source and the destination file, then it is going to show the result in such a way that the left hand arrow mark will be representing that as the lesser than will be referring to the destination branch, whereas the right hand side or the greater than arrow represents the content from your source branch. So you have to pick and then commit with the changes what it is needed. Getting it on how do you resolve the conflict in Git? Any questions, or is it clear?
Hi Adam, this is Hari. Okay, if I want to keep the same content in that and I wanted to commit it, so shall I do that?
It is up to us. I just edited the file. So now It is up to the user who's trying to do the merge, edit the file, and what content you want to keep, you keep it, because Git is going to give you both the contents by showing it, say, hey, this is the one that I'm having in the source and this is what you are having in the destination. You go ahead and choose whatever you want to keep. So if you want to comment, you comment. You want to delete. It's up to us to have the content and proceed further.
Okay. Okay. Fine. If I want to continue with the same content also, I can do again commit.
Yeah,
Am I right?
if that is the case, then you don't need
Okay.
a merge, right? So practically merge means you want to take some content. So it is up to us how to
Yes.
fix it. Basically, the point here is Git doesn't do the conflict resolution because it doesn't know what is that file, what content we have. So it is us who have to help Git in resolving it.
Okay. And mainly it compares the file name. Am I correct?
Yeah, for each file, it will try to check, and inside it, whatever contents you have, then it will be taking. So first is file to file, then in each file, whatever line you have the conflict, in each of the line, it will be showing it like this.
Okay. Fine.
Getting it?
Yes, sir. Yes, yes.
Others? Yeah, only the conflict will be resolved. So anything else that it could merge by itself, it is not a conflict. What do you mean by conflict? Something that Git couldn't do or Git doesn't know how to merge. That is what we will help by doing the changes manually and then going ahead with the commit. But for any other content that Git itself can resolve or Git can merge easily without a problem, it will proceed further, because before this we did two merge where there was no content which was having conflict. So that's why it was doing it automatically. But for any file where it finds a conflict, it will show the exact line in which it is trying to have the conflict. And even if it is in more than one file or in the same file, many conflicts that you have, everything will be shown clearly. Okay. So we saw how do we do the change, how do we commit it, how do we push to the central repository, how do we try to pull the changes from the central repository to update your workspace, git clone, and then we saw branching, how do you merge, cherry pick, and share things between one branch or the other branch, and then from your central repository to a particular local repository. So that is what as a developer workflow that we did. Now, there
Mm,
are certain,
Adam,
yes.
Adam, say there. I have one question. Actually, we did the we are resolving the conflicts manually, right? We
Mhm.
have the tools also, right? That like a K3 diff and merge some of the merge tools. We can configure or we can do that.
See, by default, Git doesn't know anything to do. Now, you have
Yeah,
the automation
only
tools that is available. Then we have to give the intelligence on writing some script on top of that. So simply, if you use that, any external command or tool that you are going to use on top of Git, you are trying to tell it, right? So ideally, the question comes is Git doing everything? No. So we have to guide some way. So if you have automation through which you can resolve, it is done. But pretty much when you have a conflict, many times we will not be resolving it automatically, because there will be always a problem if you miss something. You cannot always give the same logic or a particular logic on which the merge will be taken. For me, I should be interested in getting one kind of content. When you do a merge, you will be interested to have different kind of contents. Like someone said, I want to just commit the content and put it. So whatever could be the requirement, it is not easy to do a merge when you have a conflict automatically. Okay, so that's when many cases it will be solved automatically, but for other scenarios, we just have to help the Git to understand what exactly is our content and then do the commit. Okay, now once again coming back to the topic. So I was talking about the developer or the user workflow. Now, other than that, as a user, while he is working on Git, there might be certain other requirements that we have to help him with. So that way, now one of the scenario that we will be having is taking a backup. Now let's take that you are a user, okay? And as a user, you want to write some code to fix a problem. Now forget about branching and all those things. A simple requirement I'm saying is there is some particular workspace or a branch in which there is a problem that you're trying to fix by writing some code. Okay. Now you think of some idea and you modify some files, maybe 2 files you modify. And after modifying, before you do the commit, you go ahead and do some testing. Now, while testing, you feel that you're not getting the exact result as you wanted. And you are looking for some improvement. So that way, now what is that you will do? If you look, whatever change that you have done is not getting a result, but you are trying to focus on doing some modification to it, or you might have to create a new change or apply a new idea for it. So that way, when you want to apply a new idea, then whatever changes that you have done should not be overwritten. So practically, you have to take a backup and keep the changes, right? So point what I'm saying is when you try to do a change, excuse me. All right. So what I was trying to say is when you first did the change based on one idea, you modified 2 files, but now you feel you want to try it out with a different idea and you have to modify the same set of files again. But it is not guaranteed that the second idea that you are going to implement will be as good as first one. So that is how you cannot overwrite the contents what you have put in the first ideas based on that the modified files. So what is that we will do? We will have to take a backup of the files and keep it somewhere. Now, if it is just 1 or 2 files, it's okay. But if you have more than 2 files or multiple files, then it is difficult for us to implement it. So first problem is, how is that I'm going to take a backup when you have more than 1 files? And let's consider the same situation once again where you do the second idea and based on that you modify the files. But once again, you don't get the exact output. You feel that you want to do some changes again. So that is when you will have to once again take a backup of the second idea, all the files you have modified. So like this, if there is a scenario where you want to take a backup and the file contents should also be removed completely so that rather than adding the content, you will be trying to do the changes freshly from the beginning. So such a kind of scenario when you want to have, then you will be using a concept or a process called as stashing or stash in Git. So when you have done a change, which could be on a single file or a multiple file, and before going into the staging area or committing it, if you feel that you want to take a backup, then you will do a git stash, where git stash does 2 things. That is, no matter how many files that you have modified, it will try to take a backup of all the files, all the modifications, and then the next thing it is going to do is it will undo the changes from the file so that it will leave the file exactly as it was before you started doing the changes. Okay, so those 2 things will be done by the stash. What and all are they? It will try to take a backup of all the changes before you have the commit, and then it will try to undo the changes so that if you want to do a new change, you can pretty much start writing it from the scratch. Okay, so those are the 2 things that we can do using git stash. So let's try to do it. But before that, let's try to do some change and then try to do a stash. So now let's say I'll modify these 2 files. Okay, now these 2 files, there is no content. Okay, Watch it very carefully. In these two files, 5.java and 6.java is empty. Now what I'll do is, I'll try to put a content into it. I'll say idea 1. As I said in the beginning, we are not interested in writing the code here. Okay, so the content is not a big matter to the Git tool. So we are not worried. It doesn't mean that this is the exact code you'll be writing in Java file. So whatever they want, they can write. The concept is what we are trying to see, where I've just put a content called idea1 in this 2 file. So you can see in this 5.java and 6.java, you have something called as idea1 in each one of them. Now in this, in order to do a stash, if you do a git stash, as the name says, it will be now doing two things. What and all it is? First, it will take a backup of both the modifications that you have done, that is before the commit. And second, it will try to undo the content from this particular files that you have modified. Okay, so it will do both the things. So let's cross check that. You can see the 6.java is empty as well as the 5.java. So it has done both the things of taking a backup as well as undoing the changes from the file. So I can see that it has done a undo of the changes, so that it has left the file exactly how we had before doing this change. Now, where exactly is the backup? So to see the backup, you have to use an option called list for the stash. Okay, let me just clear it so that you can see. So how many backups we have taken so far? There is only one backup. So with respect to that, we can see that there will be an entry that the Git will be showing. Now that backup entry that it has taken is local to the repository, and it shows that it has taken a backup and it is available here. Okay, now let's go ahead and do the change once again. And on the file, let me now add a idea 2. So first time I did the idea 1, and now you can see I have added a new line called idea 2, and pretty much it is also not committed or added into the staging. So it is just available in our working directory. If I do a git stash again, what it will do? It will do two things. Take a backup of these two things, that is 2 files, as well as take the changes and undo it. So if you look now, you won't have the content. And if you do a git stash list, you can see that there will be 2 entries available in it. Okay, so like this, whenever you do a stash, it will undo the changes and it will take a backup. All right. Now, this helps the developer or a user to solve only first half of the problem. Because what is the purpose of taking a backup? So going to the requirement. Now, if you have done 2 changes and at some point of time, if you feel the first idea was the best idea that you have implemented, and so far the results that you got on the first idea's changes was the best one. So at any point of time, if you want to get it back, you should be able to get it back from the backup. That is why you store it as a backup, right? So in that case, now this other half of the requirement that we need to fulfill is from the backup, how is that you're going to retrieve the contents back to your workspace so that you can go ahead and do the commit based on that, because you don't have to rewrite everything. That is why we are doing a backup. So in order to understand how to take a backup, first let's understand on this particular part on how exactly it is trying to store the changes. Okay, now here, if you can see, it is actually showing us 2 lines of entry. Okay, now there is some concept called as array when you are trying to write a script or a program. Now, what do you mean by an array? An array is nothing but a variable that will be used in a program or a scripting or in your environment, which will be containing or storing more than one value. Now in this, if you look, it is not one single value or not one single backup. You have two backups, which means two values that you're trying to store. Okay. And in the programming concept, we call that as an array. Array is nothing but a group of elements that you want to store. You can store and retrieve. So what Git does is, Git internally uses the same array to store values. So now whatever that you are seeing stash at the rate is actually a array which the Git is using to store the backup. So in this, now there are two backups or two elements. Now what and all are they? If you look, the first one that we did was idea 1, correct? And then we had one more element called idea 2. So these are the two values or the elements that we have stored inside the stash. Now, when you are actually storing some value, how the Git will be storing is, it will not be storing as a regular way of storing from the left hand side to the right hand side, that is adding at the right, but instead it will be doing the reverse. That is, if you are trying to add a new value or a new backup, it will put that as the first value. So now if you look, whatever the latest one that you have put will be the first value, and the one before that will be here. Suppose if you do one more backup, let's say idea 3, then you will get that as the first value, and the second one would be the one before that, and the one that you had in the very beginning will be the last. So like this, it will be trying to store the values at the beginning. Now, this is how it gets stored. But I am interested to take a backup of a particular idea, right? We will not be interested to take everything. Now, if you are interested to take only a particular backup of an idea, then from this stash array or Git array, you will choose the element which has the content. Now, for that, in the concept of array, we actually use something called as index number. Now, index number is just like how you have in your book, you refer that this page number points to this chapter. Same way, now the elements that is available in the stash will be using an index number, and the index number begins with 0 and it moves on incrementally. Okay, so whatever the first element that you have will have the index number 0, and the next one is 1 and goes on. Suppose if you add one more element to it, what will happen? It will move on like this. Okay, so this is how, if you say the 0 index of this particular stash, then it will give you this value. If you say the index of 1 for this, it will give you this. If you say the second index element, it will give you this value. Okay, like this, the last value would be the first, and it will always begin with 0. So in that case, now in our stash, how many times we have stored a backup? We have stored 2 times. So with respect to that, now if you look, there are only 2 indexes available. That will be 0 and 1, where 0 represents the latest idea that we had, and the 1 represents the one before it. So that is what it is trying to show. So now here, the 0 index that it is showing here is nothing but the backup that you have taken here, and the index of 1 is going to refer to the idea 1. So based on what exactly the backup that you want to take, you have to refer to the index. So now if I want to get back the idea 1, which is of my interest because that was the best one that I feel, now what is the index number that I should be using here? I'm saying I want to take the idea 1. So what is the index number I should refer for the stash? Yes, 1, because the index 1 refers to the old idea that we had, because it goes on with the incrementing. So that is how we need to use this. Okay, so how is that you're going to apply? To apply, simply say git stash apply and give the index name in the same format what you are seeing. Okay, now if you look, what is that you are doing? You are doing two things. First thing is, from that particular backup, you are going to apply the changes from the git stash to your workspace. So now after it has applied the backup, if you can see, the file content will be exactly as you had before. So it has done. Now it is saying actually there are two files modified or modified, and in this you can see that you got back the content from your backup. So that is how you store the backup, and whenever you want you will be applying it specifically. Okay, and for that let's go ahead and do a commit, and before it I have to do a git add, right? Because we haven't done it, because when you do a apply from a stash, you are just putting it into your working directory. So from there we know the concept is, first we need to do a git add, and now both the changes will be taken together, and from this we will do a commit. All right, so like this you will be taking a backup, at the same point of time undoing the changes using the git stash. But if you look at the git stash list, what will happen is it will be available in the workspace as long as you keep it. So once you have done the commit, you are no more interested in the backup, because the actual backup that you want to store is what you have in the repository, right? Because repository is the one which is going to store everything as a backup and track. So you don't literally now need these two things available. So that is when, once you have done with all the changes, you can go ahead and do a git stash clear. So it will remove all the entry. So when you say apply, apply will just take the backup from the stash area and it will try to apply it inside your workspace. Okay, it will not be deleting it. So that's how, once your task has been done and you are no more interested in it, go ahead and do a stash clear. Getting it on what is a stash and how is that you will be applying it? No, it is a backup, as I said. If you want to directly see, it won't be possible. It is not feasible to look because the content that it will be storing is in a specific format. Clear with what do you mean by stash and how do you apply? Okay. Now, if that is clear, let's move on to the next one. That is reverting. Okay. Now to understand that, let me come back to this. Okay. If that is clear, then let me come to this. So here, when we are working, what is that we will be doing? One more thing is, now you will be doing changes here, and once you have done the changes, the next thing what you will do, you will try to put it inside the staging area, right? And after you have put the changes to the staging area, from this you will try to put it into the repository. That is the next thing that you will do. Now at some point of time, let's forget about the backup. You have done some changes and you want to undo the changes. Okay. Now, before you are going into the commit, you are actually trying to do a undo. So you can face that scenario, right? You modify something, then you realize that it is not a right change that you want to actually do a commit, then you will undo the change. Now, if it is just one line, you can edit the file one line and modify. But if it is multiple lines, multiple files itself, then it is not easy for us to keep going into the file and deleting the line, or just modifying it directly. It will be a little hectic. So that is when, if you want to undo the changes what you have done before committing, then you will be using a utility, or you will be using a command called reset. So reset means you reset the content of the file what you had before the changes. Okay, so in fact now you can think like this. When you do a git stash, it is actually taking a backup and it is also doing a reset. Okay, so reset means you are trying to undo the changes whatever on the files you have done from the workspace. Okay, so that is when, before you are going into the commit. Now, some of the scenarios when you will be doing it. So one thing is, after the user who does the modification, he will be doing a testing. So while testing, he might have got some error. And that point of time, he might be interested to undo the change. Or when you go as an organization, you will always be following some development process. And in that, one of the best practice that you will be following, regardless of whether you are a developer or a QA person or an IT person or a program manager, documentation engineer, anyone, if you are trying to do some modification, and before you roll it out to the production or before you exactly implement it, first thing you have to do is testing. And after that, get it reviewed or verified by your teammates. That is what we call it as peer review. Now, this is one of the things which the developers will be following. But as we are going into the DevOps engineering concept, and automation is the major focus in the organization, everyone is going to write some kind of code and they will be trying to store it in the tool. So pretty much now, when a user has modified some files and he has to send it for review to the peers, and within the team someone will look at the code, and if they feel that there is some change needed, they will suggest. So it is just another way of looking at the problem rather than one person's point of view. Okay, so that way sometimes you might get a suggestion saying that, hey, whatever the changes you have done might be working only for your component, but it might be causing a big problem to the product somewhere else, like that. So that is when you might have to undo the changes what you have done. Okay, so that is the requirement. But now, if you look, the changes what we actually do, let's say that I do a new change called 3.java. I modify a new file called 3.java and I would have put here. But what if before the commit, I actually put this file into the staging area? Here, still I haven't committed, right? I could have put into the staging area. Now, at the same time, what exactly happens in the repository is, when you now do a commit, the changes will be added to the repository and it will be trying to create a new commit ID. Correct? So that is the concept. But what will happen is, even before doing the commit, when you actually put it into the staging area, there will be a temporary ID created in the repository, because only through which it will be trying to refer to the snapshot what you have done. Because when you say a snapshot, it means you have done some change on top of the existing one. So the content of your file is not pointing to the latest commit ID what you are having. So that is when, as soon as you do some staging, now in the repository, it will be creating a temporary commit ID and it will be tracking it. So as soon as you do the actual commit, that will be converted into a new commit ID. Okay, so that is how in fact it will try to know that there is a difference between what you already had in the repository and what you have modified. So that way, now when you look at the repository, now if someone asks what is the commit ID on which you are working, what will you say? You will take the first commit ID, and that is the commit ID on which you are currently working, or on top of that we are trying to do some change. Okay, so that way now at any point of time, if you are pointing to a particular commit ID or you are working on a commit ID, then that commit ID will be called as the head of the branch. So head of the branch means a particular commit ID in which we are trying to work. Try to understand the word. In a branch, we have many commit IDs, right? Out of that, whatever commit ID that you are trying to work, that commit ID will be called as head of the branch because we are working on that. So that way, currently, we are working on the latest commit ID. So the head of our current branch on which we are working is this. So now if I do some change in this, what it will do is, so first thing, let me just put a reference so that you will understand. So 0EF, right? So currently, let's say in this master branch, we have 0EF. Okay, so this is the commit ID. Now there will be a head of the branch referred to this. Okay, now for that, let me remove it so that it will be easy to understand. So here, there will be a head of the branch reference, and this will be pointing to this particular commit ID. As soon as we do a new commit ID, it will be creating another 40 characters, and the head reference will be moving from here to the new one. That we know. But as soon as you put the file into the staging area, it will create a temporary ID. And because we have this temporary ID now, the head reference will not be pointing to this. So it will be now pointing to the temporary commit ID. Okay. Now these many things actually happen when you do the change. So now if you look, even without doing a commit, you have actually modified on all the areas of your workspace. So why is that I'm saying all these things? Because unlike in other tools, if you have modified a file and you are interested to undo it, it is not just only from the file, the content has to be undid, but you have to undo the changes from the other areas of your workspace in the Git. Okay, so that is how when you do a undo in a Git, that is, if you want to do a reset, you have 3 areas in Git, and with respect to that, you have options in Git reset based on which it will be undoing from these areas. So remember, undoing means it is not just only from the file directly, whereas you have to undo it from the all 3 areas based on your interest. So to do that, now the Git reset has some option, or sometimes we also call it as a reset mode. So the 3 modes that we have in the reset is soft, mixed, and hard. What do you mean by soft mode? So if you want to do the undo of only the repository changes, that is, the temporary ID should be removed and the head reference should go back to this older ID on which you were working, then you do a git reset soft. So soft mode means it will undo only from the repository. The next one is mixed mode. So when you say mixed mode, as the name says, it will be mixing both these, that is the repository and the staging. So Git will first undo the changes from your repository as well as undo the changes from the staging area also. So mixed means it will undo from both these things together. Okay. And then the last mode, that is hard mode. So when you say git reset hard mode, it will be undoing from all the three areas, that is from the repository, staging, as well as directly in the file. So hard mode means on all the three together. Okay, so to quickly understand, if you say git reset, it will undo from the repository. If you say git reset mixed, then it will undo from the repository as well as in the staging area. The same thing if you say git reset mixed, then it will undo from all the three areas in your workspace. So depending on your requirement, you will be choosing one of them. And in case if you do not pass any option to the git reset, by default it will be running on the mixed mode. Okay, so one of the common thing that you will be using is actually git reset hard, and you will not be using the git reset soft, because when you do a undo from the repository, we will not be able to see the content in the repository. That's why the soft mode will happen, but we will not be able to see. But the hard mode and the mixed mode we will be able to see, and the hard mode is the default one where you will be undoing from all the areas at one shot. Okay, so let's try to change and do the change and then try this. So first of all, do I have any change in my workspace? Nothing. And what is the commit ID on which we are working? So currently we are working on this particular commit ID. So now let me do some change here. Okay, so on that 6.java, I'll try to add a line. Okay. Now because of it, you can see that we have one particular change that have been done, and where exactly it is available only on our working directory. So now if I do a git add, it will be putting into the staging area. Okay, so you can see that it is showing in green color, and now it says it has to be committed. Earlier it was ready for staging, but now it says ready for commit. So that means now we have did the change here as well as put into the staging area, and because of it, automatically there will be a temporary ID created, and the commit reference, that is the head reference, will be moved from here to here. So let's try to undo it from all these three areas using the options. Okay, now first let me do a git reset soft. Now what it would have done, it would have undid the change and the repository, and the head reference will be back to the original commit ID. Now as I said, we will not be able to see, but at least let's check whether these two things are proper. First thing is, do you have the content in the file? Yes, that means it has not done anything to this. The same thing, is it still available in the staging area? If you do a git status, it is saying that it is in green color and ready to commit. That means in your staging area it is available. So that means reset soft will try to undo the head reference only. Now if you try to git reset in the mixed mode, what and all it is going to do? So it is going to do two things. First, it will undo the repository head reference, as well as it will undo the changes from your staging area. Okay, so this it will do, as well as it will put the head reference back to this commit ID, and then it will try to remove the contents from the staging area. Okay, so now let's go and cross check. So first let's check whether the content of the file is there. So the content is still there. That means it has not removed from the working directory, but let's check whether it is there in the staging area. So if I do a git status, you can see now it is saying that it is ready to be committed. No, it is saying it is ready to be staged, and it is showing in red color. That means the files is not available in the staging area. So that is how mixed mode is going to undo from these two. So now Finally, if I say the reset in hard mode, then it is going to undo from all the three at one shot. So none of them will be available. At the same time, now you can see the head reference will be moved once again. Okay, the very first thing it is saying that the head reference is now back to this commit ID. And then do you have anything on your staging area? Nothing. As well as, do you have the content in the file? No, it is not there. Okay, so that is how in Git we have three modes from which you will be able to undo with respect to three areas that you have in your workspace. So with respect to that, you will be using the reset soft mode or mixed mode or hard mode. Okay, so whenever you have to undo from your workspace in Git, remember you have three areas with corresponding to it you will be doing. And the general way that you will be doing is git reset hard, so that it will undo from all the areas at one shot. Getting it on how is that you will undo the change?
Adam,
Yes.
I mean, we can revert the after pushing into my central server the changes we can.
Can you repeat it?
After pushing entire my changes into the central repository, we can do the undo. I mean, reverting the changes. We can or we cannot, right?
No. As I said, central repository, you cannot modify anything in the central repository. So that is why we call it as a bare repository. So only on your local workspace, which is of the type non-bare, you can modify everything. Okay. If you want to undo something, first you undo it on your local workspace, and then with respect to that, you will try to create a new change or a new commit ID, and then you push that as a new change to the central repository. So to understand this, first we will see how is that you will undo a commit, because the concept what you are saying, forget about which repository. The first thing that we need to understand is that is a change which you have already committed, right? First we should see and understand how is that you will be undoing a commit. As of now, what is that we are doing? We are trying to undo a change before we are going to the commit. So that is when you will be using this command. And specifically when you have a scenario where you have already committed, and when you want to undo a commit which you have already done, then there is a separate method that I will focus next. But before that, is this concept clear on how do you undo a change before you are going to the commit? Is that clear to everyone?